all the way from Japan to get the new equipment for the jet stream. I was thinking, when are you coming? You know, and he said, well, Monday, and we're flying back on Wednesday. The last Tuesday in February, maybe you can speak a little bit about the wonderful research you're doing at the National Museum in Tokyo. And Hiroshi kindly agreed to do that, so Franziska Bunse is going to speak next month about the Grünes Museum, the Green Museum project. And as the people come. So it's really my great pleasure. You know, we have a long-standing collaboration with our colleagues in Japan, with Tohunken, but also with the National Museum for many years. And when we realized that Hiroshi Wada is coming and actually working on a topic which is very close to a project which is happening right now in the Rathinger project, also financed by the German Environmental Foundation, about display cases, the service compartment, and the absorbent. I was thinking maybe you can talk with us a little bit about visualization of airflow and humidity transfer occurring within the different display case. And Hiroshi Wada is the head of the conservation technology at the National Museum in Tokyo, which I know who had the chance to be there. It's a wonderful location in Ueno Park. Beautiful, beautiful location in Tokyo. And yeah, the floor is yours. And join me in welcoming Hiroshi Wada tonight. Thank you.
Thank you so much. So it's a great honor to have a presentation at the wonderful venue. So when you come here, I appreciate all of you. And special thanks to Dr. Stefan Simon here for preparing today. And yeah, this is the title of my presentation today. And I'm Hiroshi Wada from Tokyo National Museum in Japan. And I'm working as the head of conservation. And my specialty is preventive conservation. So today I'm talking about difficulty to keep the safety environment in historical building. So please watch our effort in the Tokyo National Museum. And now I want to ask you have you ever been to Tokyo National Museum? Okay, yeah, great. Yeah. So at first I'd like to introduce my museum. Very short film. So Tokyo National Museum, what? Just a moment. Tokyo National Museum is located on the Ueno Park, middle of the Tokyo metropolitan city. And the National Museum, side of the museum have a lot of green trees. That's a pity. I mentioned about the machine can show us. And okay. And we have several buildings in the museum side. So today's topic is about Honkan, Iceland Honkan. Honkan was built in 1937. So this is the main building of a museum, and they exhibit the Japanese art object. And I will introduce the short history of the Honkan. The former Honkan located in same place that was built in 1881. So this is former Honkan. But unfortunately, former Honkan was damaged, a lot of damage by the Great Kanto earthquake. So the Honkan cannot be kept the museum facility. So we rebuilt the Honkan at 1937. And from the 1937 to the present, now Honkan is kept to use the exhibition room and some part of use for the storage. Almost has 19 years old building. And Honkan have a second floor. So first floor and second floor is open for the public. Yeah. And the other floor is not open to public, is backyard for the our curator and consultant. And I try to okay. So this is a short trip to the Honkan. So room T5, this is first topic today's presentation, and it's a main entrance of the Honkan. The visitors go up to the second floor by using the great stairs. It's very famous in Japan. And the interior of the Honkan has historical circumstances. And the second floor is also exhibit the Japanese art object. This is a northeast corner. Room 4 is located in that corner. Room 4 is today's second topic. So, this is for the visitors simple map. Room T5 for first floor and room 4 is second floor. So now let's start talking about the room T5 activity. We had a special exhibition 2023 September to November in the room T5. Room T5 is has a big space, and this is the original space. So the right picture shows just built room T5 and keep the same shape to until the present. But this special exhibition exhibits the wooden Buddhism statue without the showcase. So we wonder, we are afraid the dry humidity environment affected these objects. So as we know, the humidity drying caused several damage of the wooden statue. Because we already had same place special exhibition 7 years ago. This is a record of the temperature and humidity 2016. So you can see the upper figure shows the time change versus red line is temperature and blue line is humidity. And bottom figure shows the scatter plot. The horizontal axis shows the humidity and the vertical axis shows the temperature. You can see the lot of dry humidity data was recorded. So this is danger for the wooden statue object, I think. So, and I analyzed the 7 years, analyzed that data we got 7 years ago. So I divided the data of the humidity each hour of the day. So the left top figure shows the 3D histogram. So x-axis is from 0 o'clock to the 11 o'clock to p.m. So I divided the data 24 section. And y-axis shows the humidity, and the z-axis shows the frequency of the humidity data. But it is difficult to read the 3D histogram, so I changed the graph figure format to the 2D histogram here. So you can see from 10 o'clock to the 6 o'clock p.m. the humidity is focused on around 60% humidity. But after this time period, the humidity has a large fluctuation. because our museum does not have 24 hours air conditioning. So this time period is air conditioning is working. So after closing the museum and until they open the museum, the large fluctuation was occurred in the room T5. And when start that big fluctuation, so I analyzed them deeply. So I found that from middle of the September to the middle of the October, the humidity was little moderate, around keep around the 60%. But after middle of the October to the November, the large fluctuation has occurred. So we must do some countermeasure since middle of the October. We must do countermeasure. So most simple solution is we do the 24 hours air conditioning system, air condition. But in Japan, there is a very in Japan we are facing the human resource crisis. So 24 hours air conditioning is not a money problem, but a human resource problem, because this type of the air conditioning machine require the licensed operator. So if you have a lot of money, we cannot hire the licensed operator because such people is very, the number of such licensed people is very small in Japan now. So this is a human resource lack problem, so we cannot do the 24 hours air conditioning. So the solution is, of course, it is possible to ask them work overtime at morning 2 hours and evening 2 hours. It is possible to extend air conditioning working time. It is possible. So we done the solution. We set the big humidifiers to set on the T5 room after air conditioning system down. And extension of air conditioning operating hours is one method. And plus, we bought a humidifier and set humidifier in the T5 room during closing hours. So this is a result of the 2023's special exhibition. You can see the 2D histogram. This time period is air conditioning working. And after air conditioning working time period, the humidity is still keep around 60% humidity. So this is the effect of the adding the humidifier, I think. But there is a cost of this activity. So extended air conditioning operating hours, morning 1 hour and evening 4 hours. So we must pay the operator the additional charge, 550,000 Japanese yen, maybe now 3,400 euro. And we bought 4 humidifiers, about 5,300 euro. Of course, these humidifiers can be used in the future special exhibition, but we cannot do. We don't want to again such a thing, and we cannot do same thing in every time special exhibition. So I recommend, in my opinion, I recommend if we exhibit the museum object cultural properties in the hometown, we should put them into the showcase. So my second theme is about room 4. So this is picture before renovation of room 4. So we had a project to make a new showcase for room 4. So now all the picture shows there is a standing case middle of the room 4. We changed this showcase new one. So what is room 4's environment? I will show you the room 4's environmental data. So room 4 is room 4 and room 3 is room 4 is next to the room 3, and one air conditioning machine controls these two exhibition rooms. And this data is recorded at the room 3 and 4 air conditioning machine sensor. So you can see that blue line, this is 1 year's data. You can see the blue line has a very large fluctuation. So inside of the room, without showcase, the humidity fluctuation is too large all over the year. And next, So, except for the room 4, the same situation is occurred in other room of the second floor of Hongan. I analyzed the data of the humidity all of the exhibition room at the second floor in Hongan. So this is 2022 data divided the 12 months. So from January to the December, you can see that no exhibition room shows the stable humidity. So very fluctuation of the humidity is very large all over the year, you can see. So we need a high quality case. And right figure shows the wall case in room 4, environmental data. So room 4 already has a wall case, and wall case is not a new one, very old new case, not without renovated, so very old wall case. But inside of the wall case, the data shows that better than the room 4's data. So you can see the fluctuation of the humidity is very narrow than in the room. And so the showcase is efficient to keep the good condition for the object in Hongan. And in this project, we have a plan to make a showcase similar with this type. And this type showcase we already installed several years ago in room 13, another floors. And we got the good data from this showcase. So if we make same type of showcase, we can get better condition I believe in that time. And how to keep the control the humidity inside of the showcase. In Japan, almost all the museum use the ARCSO, it's a product name, so humidity device. So we also use a humidity device. For example, this is inside of the wall case, bottom of the wall case, we put the humidity device. And we put the humidity device with a circulation fan. So we hope that control humidity efficiency with circulation fan. This method of using circulation fan, we have a lot of experience for in the new showcase. For example, Hongkong's another floors, we have a room 18. We built the showcase 10 years ago. And in this showcase, you can see the humidity device box, and with circulation fan, we made airflow in the showcase. But I don't understand clearly what kind of the airflow occurred in this showcase, and what type of the fan is better, and which position the fan set is better. I don't know exactly. So in this project, we made a mock-up showcase. At first, we made a mock-up showcase. The material is made from wood, but covered with aluminum sheet or polyvinyl sheet. And this is temporary humidification system. I will explain after. And this is circulation fan, so for the experiment. The circulation fan is something like a CPU cooler. Yeah. And we set several points for the recording wind speed. So wind speed, this is a wind speed sensor. Wind speed sensor, one measurement point needs two sensors for recording the wind speed. And first, which direction should the fan be installed? This is our question. So arrangement A, and we prepared arrangement A and arrangement B. So you can see the fan in arrangement A, the air from left to right. In the arrangement B, air from right to the left. This is only this is differences. So I'm not a specialist for analyze the airflow. So in the point of view mine, so in the arrangement A, this position and this position is in this position of arrangement of B. I think the result shows the same air speed, I think, but result is different. This is bottom figure shows the horizontal axis shows the voltage added to the fan, and vertical axis shows the wind speed that was detected that sensor. So of course the voltage added to the fan increasing the fan rotated speed. So you can compare the dot line, blue dot line, and yellow line. Blue dot line is this position of arrangement B. And yellow line shows this position of arrangement A. So at the 100 voltage, there are some differences between arrangement A and arrangement B. I don't know why this phenomenon was occurred. I don't know exactly, but there is a better correlation. Arrangement B has a better correlation than arrangement A between voltage and air speed. So arrangement B was adapted through this experiment. And we have another result of the arrangement B. So you can see the 4-dot red circle in the middle of the showcase. So each dot shows the different height level at the center of the showcase. Each height level detect the airspeed is below 0.1 meter per second. It's very small airspeed, I think. So if we install the museum object, we should put the object around here. So the airspeed of the middle position of the exhibition is better result for us, I think. And I don't know exactly the 0 centimeter height and 90 centimeter height, the most higher position, cannot detect the airspeed. I'm not the validation this phenomenon completely. So we got the information, the airspeed, and then the most important thing is humidity transmitted throughout the display case. So we should put the bunch of sensor inside of the showcase. So the blue dot shows the sensors for detecting the temperature and humidity over 60 points. And we make a frame structure and put the sensor here and covered acrylic. So in this experiment, it is better to set the humidity device also put into the showcase, and we monitoring how to change the humidity. That method is best, I think. But for such experiments, large equipment is required because a large tent should be covered this mock-up showcase, and inside of the tent, the humidity and the temperature must keep stable. And then we just start the experiment with using the humidity device. But such a large experiment, because of the budget and time reason, we couldn't do such a large scale experiment. So we prepared the mist generator. As you know, mist generator generated a high level humidity air. So high level humidity around the 90% or 80%, I don't know exactly, but the high humidity air generated from the mist generator And all of the sensors that inside of the showcase detect the high humidity. Is also I think we get the information the humidity transmission in the showcase. So this is I will show you the method of the experiment. So the red line shows the red line indicates the lowest humidity detected by all sensors. So the experiment continued until the minimum humidity exceeded the 85% humidity. So we compare the time from start to the exceed the 85% humidity. Of course, the the voltage to the fan is higher, the time is shorter, of course. So this graph shows that all of the contains all of the result. X-axis shows the airflow rate, and Y-axis, vertical axis shows the reach time. So 100, if we use 100 voltage, the reach time is 17 minutes. And if we use a 60 voltage, the reach time is about 100 minutes. And this is the visualization of the humidity transmission. Maybe here is the exhaust point from the humidity generator. So you can see the humidity transmitted widely in the showcase. And I overlapped with the image of the exhibition case, this one. So upper figure shows the 80 voltage, and lower figure shows the 100 voltage. Of course, 100 voltage is very quick, the humidity widely in the showcase. Maybe here is the exhaust. Here is the airflow exhaust from here. So this is the experiment. And through the experimental results, the humidity circulation throughout the entire interior of the display case can be achieved with a single fan, as you see. And since even at 60 voltage, the airflow reached a constant level within 2 hours. So within 100 minutes. Circulation is possible with a single fan with an airflow of about 0.1 cubic meter per minute. Yeah. So it is enough to set the one circulation fan and enough to set the lower voltage. But I think we must consider emergency humidity control possibilities. And I think we must consider the possibility of using it to absorb contaminants in displays. Contaminants means for example, volatile organic compounds from the showcase inside the material. So the conclusion is 3 100-volt voltage fans shall be installed. But we can select the number of the fans can be operated, shall be selectable. So we decided the specification for the humidity system. We fixed the plan of the showcase. This is side cross section of the display case. And another cross section view of the lower part of the display case. So 3 humidity device box and 3 duct and 3 fans. And this picture shows the making a showcase at the factory. So, Mr. Yano checked the airflow, what kind of the airflow was occurred. And finally, we installed the new showcase in the room 4. And this movie shows the humidity box inside is set. Also was set inside here. It's easy to remove outsole, and it's easy to change the outsole. And the result of the environmental data, yes. This is the newest data. I just recorded at the January in this year. So left side shows the temperature and humidity in the room, and right side shows the temperature and humidity in the showcase. You can see the humidity fluctuation is very focused, narrow range, near about 55%, because we set the outsole of 55% in the exhibition showcase. So this is the final end of the slide of my presentation. So today I want to talk about the it is difficult to keep the safety environment in historical building. Our honkan is also recorded as a Japanese national cultural important property. So it's not easy to renovate the inside of the facility of the historical building. So I hope my case study is helpful, useful to you and to your museum. Yeah. So that's all. Thank you for attention.
Yeah, thank you very much for showing us the diagrams, which are so familiar for us as well. Questions to Hiroshi Wada?
As you know, now in the laboratory we're also having one project dealing with showcases, and we also measure inside and outside the showcase. You presented this very nice scaffolding with a large number of humidity sensors for measuring inside the showcase.
Yeah.
Did you observe any differences in the results from one sensor to another one? I mean, we just bought like 5 sensors, and if we place them one next to the other, I mean, they do not show the same result. There are differences of several percent. Did you observe something similar?
Yeah.
How did you deal with it?
Yeah. Before we started that experiment, we adjusted the sensor by using the product is a Visor. Yeah, because manufactured the company was a Visor. Our company was as a sensor maker says that Visor sensor shows the humidity is the correct, more correct than other company maker. So we use the Visor humidity sensor as what should I say?
It's a reference.
Yes. So if there is differences between the Visor sensors humidity and our sensors, so we adjusted the humidity's number to the Visor sensor. Yeah.
Probably a number of questions. First of all, is it correct that you have just nearly no flow at the walls and top and bottom of your case? That that makes me assume that you may have a laminar flow in the whole box, more or less. Is this correct? Laminar airflow.
Laminar.
No, and and you have used that time an empty box.
Mm.
So the first question then would be if you have some exhibition specimens, does it change the flow in the box?
Does it change in the flow in box? I didn't understand the deeply. So what you saying that the every so experiment that we done is only recording, monitoring the humidity. So we just start time of the experiment. We monitor the air speed. So as you see the slide. So at first I want to know what kind of airflow was occurred in the showcase. But airflow is, of course, airflow is important. But most important is I got the safety humidity in the showcase. So in fact, I didn't know what kind of airflow was occur in the showcase exactly. Yeah. So almost all the experiment was done by monitoring humidity. So this is this is my answer, but it's so.
So just I'm more or less a theoretician. The point is that, or your target is, and finally, that you have your specimens in the box equally covered with a humidity, a certain kind of humidity there.
Yeah.
So but you have the mist generators,
Yeah.
they blow it in.
Yeah.
So that just how to make sure that your specimens are then equally covered with the same humidity, or are there some shadows, wind shadows or so?
So in fact, this is first step of experiment. Now we just done the second step experiment. So we made a large tent, and we made a mock-up showcase put into the large tent. And in that second experiment, we didn't use the mist generator. We used the aerosol, different types of aerosol, from 40%, 50, 60 different type of aerosol. And we we put the same sensor in the mock-up showcase, and we monitor. And that experiment is just finished. So today I can show the result of that experiment. That we already have the result of the another experiment. Yeah.
Can I ask one question? This case here, this is an experiment with the aerosol inside, right?
Yeah.
That's why you, although you experience quite a change in the temperature of the day, your sorbent keeps the humidity very stable.
Yeah.
You don't see that in the room, because in the room when you have temperature,
Yeah.
the humidity is changing actually even more, right? So this is actually showing how efficiently your aerosol probably at what is it, at 55%, right?
Yeah.
It's kind of stabilizing.
Yeah,
everything.
yeah, that's right.
I think one of the slides, I had the impression that you have a very visible difference between your summer and your winter. And you said, you know, the September to October was summer and October to November was different.
Yeah.
Can it be that in the winter, the heating of the building comes more into play because you don't maybe heat so much in the summer, I guess? So you have a kind of stable, I don't know if you've seen that, I had the impression that in some of the diagrams before, that the moment you start the winter season, you have more temperature fluctuation than in the summer. Because in the summer, the building only reacts to the outside and the, you know, insulation from outside, but in the winter, it really reacts to the heating turned on and off. Is it true that maybe that gets you more of the fluctuation in the winter time than in the summer?
More fluctuation. Just a minute. I back to the side of the. So you said about the data in the room.
Yes.
Yeah.
I think here, yes, for example.
Yeah.
So that in that time period, 12, December, January, February, is it?
Yeah.
You get more of this in this time of the year. It's more stable.
Yeah, this is you said right. This is the air heating influenced the humidity. I think. Yeah, that's right. Yeah.
By the way, this was very impressive also. This was extremely impressive.
That's fun.
Yes. Yeah. So is this the frequency or is this the humidity, right?
Yeah.
Humidity. So in the winter you get pretty dry, in the summer you get more humid, more higher value of the humidity.
Yeah.
Yes, I have a question about your whole collection because I don't know how, so not all of the objects are in display cases, right? That some of them are outside.
Yeah.
So because I see that at some point you have 70%, in other times you have 30%.
Yeah.
Do you notice over the last decade that there has been a major damage to any of the objects that are not in the display cases?
No. But I don't know.
No, I was just wondering. I understand the point we are just having a debate about this.
Yeah, this for this activity is for the special edition. All of the objects we borrowed from the other facility.
Yes. I was just wondering about the permanent, that's for decades and decades in your collections. Okay, yes.
Yeah.
Because it was only 2 months exhibition.
I have questions to your experiment with the showcase. Did you measure performance without the fan and then with 1 and 2 and 3 fans? So did you compare the switching on and off different fans and the performance of the humidity, airflow in the showcase? Yes, because you recommend 3 fans, which can be switched on and off, and interesting to have. To have an overview of, let's say, performance of 1 or 2 fans. That's one question, and the second question related to what the gentleman asked. Have you considered to put exhibit mock-ups into your mock-ups showcase? Because rarely a showcase is empty in use, and then have you considered to collect data with something in the showcase, which acts as a model of a object.
Makes a significant
Okay.
difference in the flow pattern of
So first, so I will answer for the first question. In this experiment, we didn't do that comparing. So I just said the second experiment. We done the comparing the three parts. One farm was moving and two farmers moving. Three parts. We compare, and we got already the result. But in today's experiment, we didn't do such a comparing. And second question is, yeah, we decided three farm because I think if we when we use this exhibition case, of course we put the object in this case into the inside of the case. So if we use only if we put only a single farm, for example, the center. This one and this one. This position was occupied by the museum object. Maybe the air cannot reach the end of the showcase. So we prepared the several fans in the showcase. We that depends on the shape and number of the object. That's why we selected this plan.
So I'm just a little bit insisting on the specimens in the box. There are certain objects I could imagine that they are very, very sensitive to the humidity and changes in the humidity, particularly wooden ones. So this is just why I think this is very important work you're doing here. So this just in this setup you're showing here in this slide. How about a sensitive specimen? You put it just on the bottom of your case, or you put it on a small jig or in the middle of the case, so it could be flown from below and up on the top, and in difference to that one on the bottom. So I think that could make a difference. So I could imagine that you could just not only watch the flow of the humidity, but the airflow itself. So the airflow is the carrier of the humidity. Okay. So this is what you have indicated that you have some more experiments right on around this area. I think these are just, I could only catch to these. Have you any from those already done?
I don't answer. But if we have the next chance to make a showcase, I want to do some different method to the control humidity, but I don't know now actually, so I don't have any new idea now.
Okay.
For the adsorb,
Yeah.
how much adsorb kilograms you used for the volume? Did you, one recommendation sometimes is 1 kilogram adsorb per meter cube, for instance. Is that something you use? And Do you have an idea how long it would take until the atom is exhausted and needs to be regenerated?
The maker of the aerosol recommended the 1 kilogram aerosol is used for the 1 cubic meter, and the limit period is 5 years, they said. Yeah. But our museum already had over 5 years aerosol so much, and they do efficiently keep the humidity. Because I monitored the inside of the showcase, there are no large problem. So I don't know exactly what is the aerosol limit of the use.
I mean, in some use cases you have like 50%
Yes.
in the showcase, but outside, perhaps let's say it's more dry, and then you need to regenerate your atom by putting in again a bit water so that it can maintain the 55. But looking at the climate data in your museum, you are very humid in summer and then a very dry in heating period. That is perhaps just the work of the atom is not to create a microclimate which is so much difference, but more like buffering the peaks, the high peaks and the low peaks, so that you don't need to generate that much.
I see.
And first, another question, did you also think about, because you were just in the last slide mentioning the VOCs, do you also think about including active carbon filter or something like that to filter out some VOCs or
Organic, volatile organic compounds.
We
other air pollutions?
Sometimes we found the problem of the organic compounds, and we set the observed for activated carbon filter put into the humidity box, and for using the against the volatile organic compounds. We had that experience.
Especially the Bible case.
Have there been big construction changes from the mock-up case to the end result display case? Like, as you said, that the wood from your mock-up display case was made from acrylic glass.
Yeah.
Do you also use it for the exhibition case in the end, or do you use glass for it?
Yes, steel and low reflection glass. In the showcase, this one, and we painted the surface of the steel by powder coating. And we use double layer glass.
But was there a reason for your tests with acrylic glass, or it was just easy to work with, I guess?
Because that showcase is a mock-up.
Yeah.
So because of the cost problem.
Exactly. I have one question for you. You started in this presentation with something really interesting. You know that we also do evaluate and benchmark real climate and collections and display cases. And if you go to the beginning, just for a second, because maybe everybody understood, but I didn't really understand everything very well, and I'd like to come back to this beginning on the top. I want this, first, more down. Yes, like here. Just to get an idea that we understand you know, how did you do this wonderful 3D and 2D histogram of a daily hour, like 24 hours, right?
Yeah.
The humidity and the frequency
Yes.
of how often, let's say, in a day you have 60% or 40%. I just want to make sure that because we do this to climate classification, climate benchmarking, and how did you? So you need your hourly values,
Yeah.
and you say, let's say 60%.
Yeah.
You have a frequency of 40 or something at 4 p.m. and a frequency of like 10 in the morning, right? This is how you. This is what is this prospection of the 2D from the 3D histogram of humidity. I think this is very interesting because I didn't see this before, so I think this might be a very interesting idea for us also to look at climate data. Because you explained very well the differences when you turn off condition versus when it's turned on. And I just want to give this as an idea to evaluate that, which we cannot do if we have daily averages anymore. But you know, with the original data that we have often hourly rates, we could do something like this. Similar. I think it's very, very interesting. Thank you. This is really.
Thank you. Because I don't like the time changing graph, so my brain is complicated looking at thousands of the graphs. So it's easy to evaluate the environment. So now the making a code is easier than the first time. So I asked the ChatGPT, provide the code.
Oh really?
Okay. I use a MATLAB.
MATLAB, but we have our
I like this very much. And the other question, I mean, just, you know, because it's like at least 5 people here who do this kind of evaluation, and I'm sure that I have seen this the first time, and I think maybe they also have seen it the first time. We should try that to do that also. The second thing, and please explain one more time, because I didn't understand this. It's only a question for clarification. You said the climate issue is not only an issue of energy and carbon emission and money, but it's also an issue of human resources. You spoke about climatization being operated by licensed technicians or licensed operators. Can you explain one more time what does it mean? Is there somebody sitting and working, or what is this relation to the human resources? What you said, there's a human resource cost on that. Just explain one more time because I'm not sure if everybody understood, but I didn't really understand.
I'm sorry. So our air conditioning machine, the energy source is generated from the boiler machine. So in Japan, operating the boiler is required the license. So the licensed people, the air conditioning company, we contracted the company's person. The few person come to our museum and operate the machine.
Okay.
But we request that company because for this special exhibition we need 24 hours air conditioning. But that company said we don't have any more licensed person. So this is a human resource lack crisis.
So that's why you decided 1 hour in the morning and 3 hours in the afternoon to hire this licensed person that you couldn't afford.
That is possible.
Okay.
But 24 hours conditioning system, that operator stay in the museum. So at least 3 or 4 person we need.
Okay.
That company cannot prepare such a large number of licensed persons. That's the thing.
Yeah. More questions to Hiroshi Wada? If not, I would like to thank you. I also want to thank you for remembering us the Kanto earthquake, 1923, which was, I mean, for all of us is an important lesson in preventive conservation and risk management. we all remember that the big damage was not only the earthquake, but the fire, which followed, and a tremendous loss of the city of Tokyo. And I read when I was in Tokyo in October, what a deep memory this country earthquakes has. Thank you for that too, because it's a lesson for us also in risk management and preventive conservation. Thank you, Hiroshi Wada, for showing us your wonderful research project in Tokyo and for sharing your knowledge with us. And now we can probably, you hope to join us for a glass of wine. And before we go, we can go out for dinner. Thank you very much.